Today's math lesson is just one page. It is on using circle graphs for mean, median, and mode. So mean, median, and mode are all different types of finding the average, so we'll talk about what each of those means through this lesson. This page starts with an investigation before we get to question 1. So the investigation is asking us if repeating each data value the same number of times changes the mean. So I'm going to break down what mean means and what they are saying in this question. The mean is what is traditionally referred to as average and what your parents will have learned as the way to calculate the average. So the mean is when you add up all of the numbers and then divide by how many numbers you have added. We have talked about this year, but I'm going to go through an example with you. The first step in calculating the mean is to look at your data set, so the list of numbers, so here it's 3, 3, 4, 6, 6, and add them all together. So that is what would go in the blanks here. So remember, we have brackets going around our addition. So if we think of order of operations, brackets has to come first. So we need to start by adding all of these together. So 3 plus 3 is 6, plus 4 is 10, plus 6 is 16, plus 6 is 22. So once we are at 22, then we need to divide it by 5. And that is going to give us a decimal, right? So you could use your calculator, or if you wanted to do this the long division way, 5 goes into 22 4 times, which gives us 20. We bring down the 0 because we've had to add a 0. We need to add in our decimal here, and it goes into 24 times. And now that we have a remainder of 0, we're all done. So it equals 4.4. Now, if we were to look at the second set of data points, you will see that there is a repetition of our first set of questions. So we go 3, 3, 4, 6, 6, 3, 3, 4, 6, 6. So it's almost like we have two groups of our original set, which is what they talk about repeating each data value, that we've got two groups of it. So they still only give us 5 spaces because there are 5 numbers. So we're going to put the same numbers in that we did for A, but this times by 2 is here to show that we actually will be multiplying this addition section by 2 to get what both of these sets add up to. So this will turn into 22, because remember that was what these 5 numbers add up to, times 2 divided by 10. So 22 times 2 is 44. And the reason we are dividing it by 10 instead of by 5 is because instead of having 5 numbers, we now have 10 numbers. So we need to divide it by 10. So 44 divided by 10 is also 4.4, because we just need to take our decimal. Division tells us we move the decimal to the left. There's 1 0, so we move it 1 place to the left. So it's 4.4. Part B is going to ask you if repeating the data values changes the mean. So here we had our initial data values. Our average or our mean was 4.4. When we repeated the data values, it stayed as 4.4. because we still have to divide by however many pieces of data there are, or numbers in our data set. So you should notice in your other examples as well, when you finish part A, that the same thing still applies. That if the numbers are the same and you just have 2 sets or 3 sets or 4 sets, the mean should stay the same. Part C of our investigation asks you what happens to the mode and the median when the data values are repeated. So we're going to start with our definitions. The mode is the most, they both start with most common number in the data set. Okay? So whichever number happens the most is your mode. The median is the middle number when the data is ordered from least to greatest. So they ask us to make up our own data set to show that this is true. So if I come up with a set of data that is 1, 2, 3, 3, 4, 4, 4, 5, my most common number, or my mode, is going to be 4 because there are 3 4s, 2 3s, everything else has 1. So my mode is 4, and my median is going to be my middle number. So sometimes what I do is actually cross out the numbers one at a time to get to the middle. So I go, okay, here's my 2 ends, and then I go inside one, I go inside one. So here my median is going to be between like 3 and 4. So I could write that my median is 3.5. So then to check, I need to duplicate my data. So you can see I've gone 1, 2, 3, 3, 4, 4, 4, 5, 1, 2, 3, 3, 4, 4, 4, 5. Before we can find, well, we can find our mode from here. So we've got 2 1s, 2 2s, 4 3s, 6 4s, and 1 5. So 4 is our most common number. So that will be our mode is still 4. To find the median, I need to rearrange all of these numbers so that they go in order from smallest to largest. So I would go, okay, 1, 1, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 4, 4, 5, 5. And so that should have all of my numbers taken care of. And then I'm going to see which number's in the middle. So here's my ends. Next one. We just take them off 2 at a time. And so we end up in the same position where we have 3 and 4 are our numbers in the middle. So halfway between that is 3.5. So our mode and mean actually don't change either when we repeat the data values. So for question 1, you're going to be given a frequency table and a circle graph. Now I have changed what the data is about. I have completely different numbers, but I'm going to walk through kind of what the questions would be like with these numbers. So this gray section represents the number of students who have 1 device at home. The green section is the number of students that have 2 devices. And the number in blue is for 3 devices. So if we were to write each of those as a fraction, right? So we could go from 4 out of 20, and if we divide those both by 4, that equals 1 out of 5. So 1/5 of the students have 1 device, 1/5 of the students have 3 devices, and 12 over 20, which if we divide by 4 gives us 3/5 of the students have 2 devices. So Sally is the first person that is going to set up her kind of calculation for finding the mean, and she uses the frequency table. So she makes sure that when she's putting her 1 devices in, that she has 4 of them, 1, 2, 3, 4. That when she's putting in the number that have 2 devices, there are 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then that there are 4 entries in her data for 3. And so in total, that is 20. So she would add all of those up first and then divide it by 20 to calculate her average. Tina, on the other hand, looks at her circle graph and uses the fractions to write out her data set. So she actually pretends that because we can simplify everything to 5, that there are only 5 families. So when she's looking at 1 device, 1 out of 5 families has 1 device. So she only adds 1, 5. Then she looks at how many have 2 devices. And she goes, okay, well, 3/5 of the family. So that would be, if there are only 5 families, that would be 3 of them. So she adds 3 2s. And then she looks at the families that have 3 devices, and the fraction simplifies to 1/5. So she's just using her numerator to decide how many of these to write. So she adds 1, 3. You can also see that if we group Sally's data into 4, we've got 1, 2, 3, 4, 5 groups. So 1, 1, and then 3 2s, and then 1, 3. Okay? Now Tina, because she only has 5 numbers, will divide this by 5 after she adds it instead of dividing it by 20. So question A asks us what each of them gets. So for Sally, we can look up and add all of these together. So we go 1, 2, 3, 4, and then we can count by 2s, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and then we do groups of 3, so 31, 34, 37, 40. So it would be 40, and then divide that by 20 would equal 2. For Tina, we just have 5 numbers, so we go 1 plus 2 is 3, 5, 7, 10. And then we divide that by 5, which gives us 2. So Sally, her mean is 2, and Tina's mean is also 2. Question B asks you which method you like better and why. So some of you might prefer Sally's method because it's just easier for you to understand. You need to have all of the pieces of data laid out. Some of you might understand Tina's easily, and so you like it better because there's less numbers for you to add. There is not a correct or an incorrect answer here. It's just a preference of which one you like and being able to explain why you have that preference. The final part of question 1 says if Sally accidentally divides whatever her answer is by 10, so I just use my data of 40 by 10 instead of 20, she would get a mean of 4. So how would she know she got the wrong answer? Well, if she looked up here, 4 isn't even an option. Nobody had 4 devices. So that doesn't make sense for that to be correct. Even if she had anything above 3, like 3.1 or 3.2, you would need to have numbers bigger than 3 in order to get that. Question 2 is going to give you a circle graph that is filled with data on kind of the annual incomes of people in a developing country. So once again, I have changed the numbers. I'll do a different kind of set of equations with you, but it'll be the same format as your book. So the first question here is to use the circle graph to find the mean, median, and mode, and their hint is to pretend the country has 360 people. Now, if their hint is that the country has 360 people, 360 people and a circle should make you think angles. So we will be breaking out our protractor to figure out the angle of each of these sections to figure out our kind of randomized data for how many people fit into each section. So I have my protractor all lined up with the base here for the blue section. And this, I have my data completely backwards, is apparently the section of people that make $65 a year. So this data is going to be very different from yours, but that's okay. Most people are billionaires in this country, aren't we? Wishing we lived there. So if we follow this through, it comes basically right to that kind of 5 mark from the 0, right? That first medium tick. So if this was 360 people, our $65 employees, there would be 5 out of 360. My green section is the group that makes $35,000 a year. And so if we look, here's our base lined up with 0. And the other arm goes directly to 10. So this would be 10 out of 360 people. Now to figure out how many people make a billion, this is very inaccurate. Please, this is not even close to what salaries are like in developing countries. We can just look at how many people there are left over. So if we had 360 altogether, and there are 5 and 10 that have the other ones, that's 15. 360 minus 15 is 345 out of 360 people. Now, if we wanted to simplify each of these fractions, but have them still have the same denominator, we could divide each of them by 5. So 5 divided by 5 is 1, and 360 divided by 5 is 72. 10 divided by 5 is going to be 2 out of 72. And then this one should be 69 out of 72. To find our mean, we need to add up all of these kind of numbers together. Now, this is where we're going to make some things a little bit interesting. So we're going to have 165. If we just kind of pretend that there's 72 people and we work with these fractions, we are going to have 2 people that make 35,000, and we are going to have 69 people that make $1 billion. So if we were to multiply these out, that should give us 65 plus 70,000 plus 69 billion. So we can add this column together. So we would have to think of lining everything up. So the 65 would be on the end. So we'd have 5 and 6. We have no hundredths here. We have 70,000. We have no millions. And we have 69 billion. So instead of writing out 72 numbers and adding them up, this is a different way you can organize it when you're dealing with a big number like 360. So you can just kind of multiply what each section would be and then add them up. We still, however, have to divide it by 72 because that is how many numbers we've added together. So we would need to go 69,070,065 divided by 72, and I'm going to rely on my calculator for this one. So that's going to give us 958,334,306.46. So I have rounded to the nearest cent. So this will be our mean. Our mode, our most common number, is going to be 1 billion because there's 345 out of 360 people that are making $1 billion, according to our very inaccurate data. The median is also going to be 1 billion because if we were to even just write out 72 numbers, we'd get a 5, 2 tens, and then everything else is going to be a billion for the next 69 numbers. So obviously the number in the middle is going to be 1 billion. Question B asks you why you don't need to know the population of the country in order to calculate the mean salary. And so if we think about our previous question in investigation 1, what happens when you repeat a data set? So we found in our investigation that when you repeat a data set or a group of numbers, the average doesn't change. So it wouldn't matter whether we are basing all of our fractions from the circle out of 72 and we're simplifying things. It wouldn't matter if we were getting them to be out of 360. It wouldn't matter if we were getting them to be out of 100. We would still be getting the same proportions, and so our average would not change. So it doesn't matter how many times we repeat the data set. To go for a population of thousands or millions, you'd just be repeating that data set over and over again, but that won't change your average. The next question asks, would you move to this country? Why or why not? Now, my mistaken data, you might really want to move to the country that I've presented you because the odds are actually very significant that you would make $1 billion a year. However, you'll probably find in your questions that most people are not making $1 billion, that it is very few that are actually making that amount. So the final question is asking you, if you wanted to move to a country with a good average income, would you look at mean, median, or mode? So basically what you're looking at is which ones are the hardest to manipulate or to hide the data, right? So if you had a mean, if you had 1, 2, 3, and a million, your average is going to seem quite high, even though only one person is making $1 million. Most of them are making $1, $2, or $3. The median might be harder to manipulate because you're looking for the middle number. So every time you take off somebody from the high end, you also take off somebody from the low end. So that might be more realistic. The mode is going to be quite a good marker. Like the mode will tell you what the most common is. So it'll give you your greatest odds of, okay, that's my biggest chance of being in that category. So I would definitely stay away from mean. You can come up with your own arguments for why you think either median or mode would be the best type of average to look at. As always, when you finish your work, let me know on FreshGrade in a comment whether you need some extra help or whether everything went fine. Hope you have a great long weekend, and I'll talk to you guys soon. Bye!